presently, as you all are aware, that we are going through a series of operating system concepts, and the topic which is being considered presently is about file systems. And in our previous lecture, we have also seen about the file system interfaces, in which we have understood what actually file system, what are the basic components of file system are. And today's topic is about the implementation level details of this file system. So in order to recap and to give a push to our today's lecture, let's try to have a recap in a nutshell. So basically, a file system is one of the most critical components of any of the operating system, along with other components like disk scheduling, CPU scheduling, and so on and so forth. Basically, as indicated, file system is responsible for organizing and managing the files and directories. These files and directories are organized and managed on various storage devices, for example, your hard disk. Then what are we going to cover in today's lecture is about the details of file system implementation, its key concept, the data structures, the allocation strategies which are being used here, and other strategies which are employed to ensure efficient and reliable file storage. So in totality, we can say our file system file system defines the structures and methods for storing, retrieving, and managing files on the storage devices. So each and every detail which is related to storage of files, retrieving of files, and managing files on various storage devices comes under the purview or comes under the umbrella of file systems. And what is the purpose of the file system here is, the purpose of the file system here is to provide an abstraction between the user and the applications, so that users can interact with files and directories very easily without any hassle. So that layer of abstraction has to be provided by file system. Now coming to the various components of file system, so we have seen that the components here are files, directories, file metadata, and file operation, along with directory operations also. So file, as you all are aware, a named unit of data with which is having some metadata and elements associated with it, and these elements and metadata are representing the information about the user of the file. For example, who has created it, when the file has been created, when the file has been modified, and other pieces of information. Then coming to the next component, which is directory. Basically, directory is a container that is going to hold the files and other subdirectories, and we have also seen the tree level structure of a directory in our previous lecture. So nowadays these directories are we can say arranged in the form of these tree level directories, tree level structures. Then I was talking about the file metadata. This file metadata is every information about the file. For example, the name, size, permission, timestamps of modification, of creation, and where it is stored within that storage device. That means the complete path or location, we can say. All these pieces of information combines together and form the metadata of the file. Then there are operations related to the file which are very common, like creation of file, deletion of file, reading from file, writing into the file, and modification of files, and so on and so forth. Now with these levels of with these details of file systems, let us try to see, when we talk about the actual implementation of file system, what all details we are going to study, we are going to cover. So in case of implementation, the first level detail, or the first thing which is covered, is about allocation methods. So these allocation methods are the methods which are there or which are employed in order to manage the allocation of disk space for storing files. So here these files, or various files, or I can say each and every file, is stored onto the disk, and in which manner it is going to be stored onto the disk, what is the structure, what is the way of storing a file onto the disk it is going to be. So all these details comes under the allocation strategies or allocation methods. So basically, the main allocation methods are, three. One is continuous allocation, another one is the linked allocation, third one is the indexed allocation. So we will see all these allocations: continuous allocation, linked allocation and index allocation in the detail. Let us begin with continuous allocation. So continuous allocation, as the name indicates, files are stored as the continuous sequence of blocks on the disk, and each file is going to occupy a set of continuous disk blocks, making it easy to read and write the data because everything is done in a sequential manner. And in order to track a particular file, the information which a file system has to maintain is about the name of the file, obviously, which or identifier we can say, or tag of the file, and then what is the starting block from which particular block this file or the data of this particular file is going to be started, and then what is the length of the file in terms of blocks. So that is the only kind of information we can say has to be maintained. Let us try to see an example with the help of a figure which is available on the screen. So here we have names of the some files written on the right hand side, which are count, tr, mail, list and f, and there are two other columns which are showing the starting block, the number of the starting block and the length. So for example, the file count, if you can see, is shaded gray on the hard disk structure, and hard disk here, if you can see here, it is in the form of blocks, I can say, and these blocks are numbered. So in the first row of the hard disk, you can say you can see 4 blocks numbered 0, 1, 2, 3 followed by 4, 5, 6, 7, and the blocks are arranged sequentially. So when we talk about continuous allocation, let's say we start a file which is named as count, and the start is the block number 0. These are the blocks numbers, and what is the length? So for two blocks this particular file count is spanning. So for the block number 0 and another which is block number 1. Similarly, we have tr, which is starting from 14 and spanning or is allocated for 3 blocks. So you have 14, 15 and 16. Then you have mail, which is starting from 19, again a grey shaded area, going for 6 blocks starting from 19. So 19, 20, 21, 22, 23 and 24, and similarly the two other files which are list and f. So this is what your continuous allocations say. You take a file and then you start storing that particular file in the form of continuous blocks on the disk, and each file is going to take a set of continuous blocks. That's why the reading and writing process is very easy, because everything is going on in a sequential manner. But with this strategy, here comes some pros and cons. So as far as pros are concerned, I've already told you that this is a very simple and efficient for sequential accesses, and there is no need to maintain any complex data structure for file allocation. We can say what complex data structure I'm talking about is in other allocation methods. We will be using some linked list and some other data structures which are not required here, because everything is going on in sequential manner. What about the disadvantages? The biggest disadvantage with continuous allocation method is the fragmentation. So here you can see the way in which these files are stored. Now let's say, for example, I want to store a particular file which is having a length of 5 blocks. So I cannot store it starting block number 2, because there are no 5 continuous blocks available. Only 4 continuous blocks, 2, 3, 4 and 5 are available, 6 and 7 are already filled. So in this situation, I cannot store a file of 5 blocks here, and here because of this thing, it is going to give a shot to internal as well as external fragmentation both. And another situation in which, let's say for example, I have a file which is named as mail, starting from 19th block, and the length is of 6 blocks. Now what if I want to expand this particular file for let us say 4 more blocks. So 4 more blocks, that means presently it is ending on 24th. So then 25, 26 and 27 and then 28. But 28 again is already we can say occupied, so I cannot expand it. So then there are limitations in expansions also. So it is going to give a difficulty in expanding the files, because expanding a file requires a continuous block. This is what our strategy is, the continuous block allocation. So we may not have that continuous block of that sufficient size which is enough for the expansion of the file. So this is a challenging task to find that particular block in terms of continuous allocation. If it is the space is very much fragmented, then it is more of a problem altogether. So with this continuous allocation scheme and its we can say pros and cons, let us try to explore another scheme which is about the linked allocation. So linked allocation, it overcomes the fragmentation problem, which was one of the most prominent disadvantages of the previous strategy, which was continuous allocation. So in linked allocation, there is no we can say fragmentation. Fragmentation problem has been overcome by storing the file as the linked list of the disk blocks, and this is what I was talking about in the previous strategy, that there are no usage of complicated data structure. But here, in order to make it more efficient in terms of storage space, we need to use linked list of the disk blocks, and that is why this strategy is known as linked allocation. So this overcomes the fragmentation problem, because this is going to store the file not in the continuous blocks, but as the linked list of the disk blocks, and each block contains a pointer to the next block in the file, and thus forming a chain, as we can see in a linked list. Now how it is going to we can say end, that is the last block of the file contains a special value, maybe a sentinel value we can say, which indicates the end of file. It could be any end of file EOF mark, or it could be a value which is -1 or something of that sort. So a special sentinel value which will indicate that this file is going to be end here and there are no more other pieces. So here if you can see the example of this particular allocation. So we have a file named as Jeep. It is starting from block number 9, if you can say. So from block number 9 it is going, if you can see, if you can follow that linked list. So from block number 9 it is going to block number 16, then from 16 it is going to block number 1, then from block number it is going to block number 1, from 1 it is going to 2, and then from 2 it is going to block number 25. And please we can say notice the presence of a -1 value inside the block number 25, which indicates the end of file here. This is the special value I was just talking about. So -1, the presence of -1 indicates that it is we can say the file is going to be end here. So only the start and the end mark or the end block has to be specified along with the file, and the rest of the we can say flow is being taken care by the presence of that particular linked list of the disk blocks, which is directing. So from 9 it goes to 16, from 16 it goes to 1, and then so on and so forth. So this was the example of your linked allocation. Now coming to the characteristics, advantages and disadvantages of this linked allocation. So the first advantage is there are no fragmentation issues, because files are already we can say scattered across the disk. So no fragmentation issues are there, and because of this quality, it is efficient for sequential as well as for variable length files or the fixed length files. It is efficient for both of the files in which the length of the file is variable or the length of the file is fixed. Now, seeing at the disadvantages because the whole file is going to be traced or is going to be tracked with the help of a linked list, then in this situation random accessing a file becomes slower because it will take time to traverse the linked list. So, that is what the issue with this. Also, there is an overhead of storing pointers of these linked lists. Along with this overhead in terms of time, this is also presenting an overhead in terms of extra space which is required for storage of that pointers, and also the disk blocks may become scattered, leading to inefficient disk access. So, access is going to be we can say little inefficient, yes, little slower, that is also fine, but the storage and the space which we can say is being utilized here till till its optimum, and there is no fragmentation problem as well. Apart from that, if we can see the third strategy, so we have seen continuous allocation, we have also seen linked allocation. Now we are coming to the third strategy or the third allocation method, which is indexed allocation, and the indexed allocation basically uses an index structure to manage the file blocks. Here each file is having an associated index block which is generally known as index node or inode, and this index node is having pointers to all the files belonging to the to all the blocks belonging to the file, and this index block acts as an address translation table which is providing the direct access to the file's data blocks. So, we have an inode in which all the pointers to all the blocks containing blocks belonging to the file are being stored, and this is you can say it is a kind of an address translation table which is providing a direct access to the various data blocks of the file. Coming to the advantages and disadvantages of this is with this strategy of indexed allocation is very efficient for random access to the files. There are no external fragmentation issues, and it also allows the storage of files which are of variable length, but with there comes certain disadvantages, which is like extra space overhead, as we have seen in the previous strategy also, but here in the previous strategy which was linked allocation, that extra space overhead was for pointers, we can say. Here this extra space overhead is for the index block, and thus it is going to keep a we can say keep a tab on the limit on the maximum file size. And apart from this, another disadvantage is additional disk access is required for accessing the file due to the indirect addressing. So, our index block is there which is providing, we can say, an indirect address to the file. So, an extra disk access is required. That means that first that index block has to be accessed, and then the information will be taken from that index blocks, and then someone can reach or your head can reach to the file. So, additional disk access is also required. Now, here if we can see the we can say example of this, we have, let us say, a file named as test, and some other metadata is being stored in the second column of the directory entry. And then we have the starting block as 217. It is going to give a direction, or it is going to direct the head to 618. Coming to the 618, it is going to direct to 339. These are block numbers actually, and then this 339 is it is not directing further. So, basically that is, we can say, is a kind of end of the file here. So, in this way this indexed allocation is being managed, that within the file allocation table you have pointers which are pointing towards pointing from one particular block to another particular block, or it is going to give a direction to the next blocks as well. So, here till this point we have seen all the three strategies of allocation of spaces, allocation, or we can say file allocation strategies, and these file allocation strategies are continuous allocation, linked allocation and indexed allocation. Or in this, all the three methods are having their advantages and weaknesses as well. So, many a times in modern systems, in order to balance the performance and the storage efficiency, some file system often combine these allocation strategies. These allocation strategies are combined so that the advantages of the strengths of these allocation strategies which are being combined can be taken, and simultaneously or parallelly we can say the weaknesses corresponding to various strategies can be mitigated. So, one such example here is multi-level indexed allocation, which is a combination of continuous allocation and indexed allocation method, and with this combination strengths of continuous allocation and indexed allocation methods has been we can say utilized, while their weaknesses has been mitigated. So, in order to balance the performance and storage efficiency, sometimes your file systems may take some these special methods or employs these special methods. Apart from the allocation strategies, we have some data structures which are prevalent, which are we can say widely used in maintenance of these file system or in the implementation of file systems, and these data structures are one we have seen is the indexed node as inode. Another one is the data blocks. That data blocks we have also seen, which are the actual storage units for the file data. Then we have index node as inode, which contains the metadata about individual files. What metadata here I am talking about is permissions, timestamps and pointers to the data blocks. Pointer to the data blocks we have already seen. Then we have super blocks which are widely used data structure is the super blocks are there to store metadata about the file system, including free space, what is the type of the file system, and some overall structure also. With these small but important concept of data structure, there comes one more term which is journaling file system. Journaling file system is basically we can say taking a log or recording a log of each and every entry. So, journaling basically provides a higher level of data consistency and recovery in case of system failures or in case of system crashes. So, whatever changes is being done in the file system are first recorded in a log before being applied to the actual file system, and in event of a crash, this log can be used to restore the file system to a consistent state. So, this is what is kind of we can say actually is a very important term. Generally it is known as journaling file system but actual meaning here is about the logging. Then there are some advanced file system features which is about the file system security and file system optimization, and that includes some very important terms like ACL, access control list. Then we have providing encryption and file level security mechanism in order to protect the sensitive data from unauthorized access. So, all these things goes under the topic of security we can say. Coming to file system optimizations, file system security we will be covering in greater detail in our upcoming lectures. File system optimization basically includes your caching, which is frequently accessing, keeping frequently accessed data in memory to improve the performance, then defragmentation of files, and then compression of files in order to save the storage space. All these topics, we can say, comes under the file system optimization. And as we have seen, various details about the implementation and interface of file system, we should also see some examples of real world file system, and these examples are FAT32, which is file allocation table, as in FAT. It was commonly used in the older legacy Windows system, but as indicates it is FAT32. It has some limitations in terms of file size and partition size support. Then for Windows there comes new technology file system, which is NTFS, used in modern Windows, supports large file size, various encryption and logging techniques. And another one is ext4, or the fourth extended file system, which is widely used in the Linux system, providing large files, partition size support, and journaling, logging and other advanced features also. So in this lecture what we have covered is about the details of file system implementation, what are the elements of the file system, and then we have seen different allocation strategies. Apart from allocation strategies, we have also seen some terminologies like journaling, then we have seen optimizations, file system security and protection we will be covering soon, and we have also seen some examples of the real world file system which were being used or which are being used. And here is a list of references which is being used for the preparation of the lecture. Hope you have enjoyed the lecture. Thank you for a patient hearing. I will see you in the next lecture. Till then, goodbye. Take care.